Rồi Đạt, có đây chưa? Nghe nói không? Alo.
Alo.
Ừ. Nghe nói rõ không?
Ờ, Sao phải lấy tranh cái khác.
Ok. Cứ chuẩn bị khi nào ready thì mình làm.
Alo.
Rồi, nghe rồi. Để anh vào anh ping các bạn vào đã. Ok. Cool. Rồi, ready chưa? Alo, nghe nói không?
Ok, em nghe được. Sẽ sang
Rồi.
tiếng Anh hôm nay.
Hả? Ok, này chúng ta làm tiếng Anh nhé. Chuẩn bị một cái để design. Em dùng Dryo cũng được hay là Whimsical cũng được. Cái gì đấy, em pick cái gì mà em thích.
Ok, em
À,
dùng
đó, để design thì anh phải xem màn hình, anh phải cho em cái quyền xem màn hình. Ừ.
giờ này bình thường giờ ngủ của em rồi đấy.
Ok.
Giờ này em dậy sớm.
Ok, ok, ok. Rồi, thế thì chúng ta làm trong vòng 45 phút chuẩn luôn nữa. Ok, ready chưa?
Okay, let's start.
Hả? Ready chưa?
Let's start, yes.
Hả?
Oh no!
What?
Thằng Dung của em chưa có quyền share screen để em.
Chưa, anh chưa cấp cho em đâu. Một tí. Ủa? Em được share screen mà, em có quyền share screen nữa.
Màn hình em không?
Ừ, anh thấy màn hình của em. Đấy, có thể dùng music. Ok, Scarlet Draw cũng được. Đấy, cool. Thế thì đánh right, cool. Đánh live lên Facebook nhé.
Ừ.
Ừ. Right. Alright, lên EngineerPro. Alright, cool. I like. Mọi người lấy nha. Đấy, chuẩn bị. Ok, cool. Chúng ta đã livestream rồi. Ok, xin chào mọi người. Hôm nay tối thứ bảy quay lại với EngineerPro. Thì hôm nay chúng ta sẽ có một cái buổi demo system design với bạn Vi Thành Đạt, học viên của EngineerPro. Thì bạn Vi Thành Đạt cũng hiện đang làm việc ở Shopee Singapore nha. Đạt có thể giới thiệu sơ qua về mình được không trước khi chúng ta bắt đầu?
Ok. Tiếng Anh, tiếng Việt anh. Rồi em giới thiệu
Em cứ
hết.
nói tiếng Việt đi, khi nào bắt đầu Đâu đó thì chúng ta có tiếng Anh.
Hello mọi người, hello anh Hòa. Mình là Đạt, mình thì bây giờ hiện tại đang làm ở Shopee Singapore được khoảng ờ, hơn 2 năm một đeo. Thì mình làm ở team order, cái team mà manage cái business chính của Shopee. Thì kiểu nó giống kiểu như là một cái contract giữa Shopee, um, order thì nó là một cái contract giữa Shopee buyer với cả seller ấy. Thì cái team order thì là cái team fulfill cái contract đấy. Trước thì mình làm một cái team gọi là buyer order, cái team gần front end hơn. Mọi người tưởng tượng mở cái app Shopee lên ấy thì có cái list order của mình ấy, là pay, trả tiền này, đang ship này, nhận hàng này, rồi complete. Thì là trước mình ở cái team là manage cái đấy hết, thì tương đối là stateless, có cái Elasticsearch với cả mấy cái MySQL database để mà manage mấy cái operation luôn thôi. Còn mới chuyển sang một team cũng tương đối hay, tính tiền trả cho seller.
Ok, mọi người làm về khá tính tiền đúng không? Ok, cảm ơn Đạt đã đến ngày hôm nay. Vì Đạt đã làm ở Shopee rồi thì chúng ta sẽ không bao giờ, em đi của em sẽ không bao giờ gặp những bài system design về những thứ em đã làm cả. Mọi người thường hỏi khác đi nha. Thế thì hôm nay yêu cầu của các bạn thì các bạn cũng chia sẻ là các bạn thiếu kỹ năng trình bày trong tiếng Anh đúng không? Nên là hôm nay thì rất cảm ơn Đạt đã chấp nhận là chúng ta sẽ mock buổi system design interview bằng tiếng Anh. Thế, ok chưa? Are you ready?
Okay, let's
Okay,
start.
yeah. So now we start. All right. So time for coming to the interview. We will have around 40 to 45 minutes, right, to finish one system design. All right. So let me paste the questions. I hope you can see it. Okay, I paste the question here. Right. You see the questions, and you can paste it on your screen. Right.
Okay.
Right.
Design a social network.
All right. All right. So today the question is to design a social network. So we have 4 feature, right? First, user can post. All right. Like in Twitter, Facebook, we can post, right? And the post could have text, photos, and video. Secondly, user can follow other, or they can add friends. Third one, user can see other people post. And the last one, user can get the latest updates from their friends, let's say. All right. So that is a simple requirement of this.
Okay, gotcha. So I think this is pretty straightforward for a social media site, pretty similar to Facebook or Twitter. So let's go into functional requirements first. I think for a social media site, right? First, like the user needs to be able to register a new account, log in and log out the site, so that they can post their posts, right? So maybe this is not our essential requirement. Let's go with authentication.
Right.
Yeah. And users can post text. It's similar to the problem. Photo, right. Videos. Can I assume that so on Twitter, right? A post. Can I assume that this is only one type of media? Like you have text and a photo, you have text and or video and video. So either text alone and text and photo.
It can be a combination, right? This can be a combination.
Okay. Combination of videos. Right. Users can follow others. let's go with the Twitter model here, where the users can follow others and the others can follow the user, and not like the Facebook model. Is that okay?
Okay, follow or add friends. They can add friend, right? We can make it general. It doesn't need to be like completely fit with Twitter or Facebook. It's just a general social network. Right? So maybe there's two functions. One is follow, one is add friend.
Can follow others / add friends. And then users can see other people posts. This is a feed feature, right? So they open the site and then there will be a feed there where they can see their friends or their following accounts posts.
Yeah, so this one you can combine the last two, so they can see other people posts, of course, and they can see the update from the friends. So when they log in, the first thing you will see probably the latest update.
Latest updates from friends and following accounts user follow.
And what I mean by user can see other people posts mean if they are friend or the posts are public by the owner, so they can see that. Let's say you go to your friend page, right?
Yeah.
So you can see their post, even though the post is not latest, but you can still see it.
Okay, I see. So
as long as the post is public, right, or the post is from your friends, so you can see it, right?
So I'm hearing two things here. One is posts from friends. Does that mean that like this is random accounts posts?
So
or is it just posts from your friends?
We can simply make it like as long as the post is public, we can see it.
As long as the post is
public, or the post is from our friend.
Okay, so two things. Latest updates from friends or accounts users follow. Okay. Public posts. So this is like chronological feed, like sorted by time from friends and other public posts. Because public post is very large, right? We're potentially seeing the whole post here. So there needs to be some kind of relevance, like friends of friends or the topic.
Just make it simple. So we don't make a very strict privacy setting here. We just assume it's private or public. So let's say if I have a URL related to a post, right? And I click on that URL, it redirect me to the post. And if that post is public, I can see it, right? That doesn't need to be a feed. It's just a post. Maybe the post is 1 year ago, but it's public, so it's not related to the feed. But if I click on the URL, I can go to and see that post. As long as it's public.
So this is the public post with URL.
Yeah, that type of thing.
All right. Okay. So there's a post here has privacy setting.
We can make it simple at first, because I don't think we have time for the privacy setting discussion. If we have time, then we can discuss it later.
Okay.
So for simplicity, just make it private or public. That's it. And we care about public.
Okay. So this is our functional requirements. Let's go to non-functional requirements. So I think for a social media site, it's availability is important because I mean every minute of downtime is like adds money loss, right? So availability and scalability, because like the usage of the user comes up and down in random times, like World Cup or some arbitrary event. So we want it to be
what does
scalable.
mean by scalability? What does mean?
It means that the system is flexible to the user's load.
All right. Yeah. Just go
Okay.
for it.
And low latency. We don't want our user to wait like 2, 3, 4, 5 seconds for the feed to load or the post to load. Yeah. And for this is specifically for the feed, the data. Let's see. It can be served in near real time. It doesn't mean that if my friend posts, right, I can see it immediately. It can show up on my feed after maybe a couple of seconds. Does that sound all right?
All right.
Okay, so if we're okay with this, we move on to estimation.
Okay. So what do you mean by data consistency near real time? Can you elaborate more? What does mean?
So if I'm friends with A, right? When A posts, it doesn't immediately show up in my feed, although it's the latest post that I can see, right?
All right. So you mean that you will try to achieve the latency, but it doesn't guarantee it's a real time.
Yeah.
Okay, maybe we can discuss it later. Yeah, just me.
Okay, so is it fair to assume that we have 100 million daily users?
Okay, you can assume the daily user 100 million, right?
Okay. For I think each user can have 2 posts a day on average, and so that's 200 million posts per day. What do I need to consider? So for friends and following, I assume that most people have 100, maybe 200 friends.
All right, averagely.
On average. And then maybe some people have a very large following. Okay, most people have 200 friends on average. So this means that we have, so for posts with text, photo, video, I think it's gonna take to maybe 4 megabytes on average for a post. So for storage, post storage, we have 200 million times 4 megabytes per day times 1,000. This is 3 years, equal to
what is this 4 megabyte?
I'm assuming that the average storage for a post is 4 megabytes.
But not every post will have photo and video, right? Probably
Yeah.
most of the posts will have the text, right? Usually most, like nearly 100% of the posts will have text. But how about photo and video? Not all of them have.
Okay, then let's calculate that separately.
Mhm.
So storage for media, and then storage for posts with text. 400. Maybe let's take better, like 280, 400 characters. So 300 maybe for text plus 100 bytes. Oh no, yeah. Bytes for text, 100 bytes for data. So this would be 200 bytes, 400 bytes. This equal to 130, 200. 1 billion bytes equal to 1 gigabyte. So 200 times 400 equal to 8000 gigabyte is equal to 80 terabyte. Suspiciously small. Am I correct? Okay. What else do we need to? So for read versus write, we're gonna have the ratio of maybe 10 to 1. Does this sound all right?
So one post will, okay, the ratio is 10 to 1. Yeah.
Okay, and 1% of posts will have media, which maybe around 1 megabyte on average. It's 1 megabyte to maybe 500 kilobytes on average. How many posts do we have here? So 2 million times 500 megabytes times 1,000 days, which would
It's only 1%, which is 2 million. Yes, that's correct.
okay, so 2 gig times megabytes. This is 1 GB.
1 terabyte, right? It's not 1 bit. right?
1 terabyte.
Oh, okay. 1 petabyte, 1 petabyte. All right.
Yes.
Okay. The read-write ratio probably is 100 to 1. It's not 10. Usually.
Okay.
Mhm.
Okay. This should be all right for estimation.
Mhm.
Okay. Let's go on to we have a data model. For data model, we have user. So user with username, password, hash, post with post ID, with user ID here. Post ID, text, media, URL, and then privacy. This can be either private or public. And then we can have the following user follower table with user ID and then the follower ID. This is also user ID. Yes, and if user A follows user B and user B also follows user A, then they are friends.
So friend mean A, B, and B, A are in the same table, right?
Yes.
All right.
Okay. Missing anything here? We have post, we have follow, we have feed. Okay,
You see the feed we want to get the latest. So do you think we missed some field?
Oh yeah. So we can have creation time and then verify time here for the post.
And do you think the post you miss anything?
And post user ID.
Right.
Okay, this should be good. Okay, if there's no other comments, we can go into the
one thing in the post you have media URL, right?
Yeah.
Does it mean that one post can only have one media, or one post can have multiple media? Let's say in the post, can I upload 2 photos at the same time within a post? How do you store that?
I mean, if we support, so you want multiple media in a post.
In a post, I can post 2 photos, right?
Okay, so
right.
That should be
that it is valid for me to post 2 photos.
Yeah.
And how do you know which media is it? Let's say it's a PDF file, or let's say it's a photo, or it's a video. How do you differentiate it?
Okay, then maybe we need a table for media. So media, we have media ID, media URL, media type.
Okay.
Is there a case where we ever access? I think it should be okay for us to put this into the post table as well. What do you think?
So you store media IDs as a list inside the post. All right, we can temporarily keep it there.
Post ID should be.
But you need to think of how you will query the media belong to a post later, right? You put like that.
Query media belongs to the post.
Right. If I have a post, if I want to load a post and I want to load the media with it, then if you put like this, later you need to think how you will load the media. Yeah.
Okay. Yeah. I see. You are. Okay. Well, I think we can think about this later.
Okay, we can think of it later. If you keep it like that, we can think about it later.
All right. Then shall we move on to the high-level design? Okay. So I'm seeing a couple of features here. So we have first we have a client. The client will interact with our application through a load balancer, and then this load balancer will talk to a couple of services. So first we have alt service. Post service. Follow service. And then we have feed service here. Each of these services would talk to, would store their data in a database. So post database, maybe media, store the media in object storage. This is I can edit the name of this. DB, post DB, and then follow service, follow DB. And then, okay, for the feed service, I'm thinking of storing the feed in cache. So for each user, we would have like a cache key of something like user ID, and then a feed with a list of post ID and timestamp.
Why do we need a cache here? Why do we have a DB?
Why do we need a cache here? Because I think a feed should be low latency latency and querying and writing, because a user feed, right, is constantly I'm imagining that it's constantly being updated by their friends adding posts, or by them following someone and then their post is added to their feed. So in-memory cache is like good for this purpose.
Okay.
Yeah.
So why can't a DB fit in this scenario? Why do we need a cache? That's the question, because you directly jump to the cache, right? I want to understand the logic here. Why do we use just a DB? What is the benefits of using a cache here?
For quick access of their ID list, of their feed. Let me see. So if you have like a consumer for the feed database or cache, right, it will constantly update the record of the user. So a lot of read and writes. I'm thinking that it's too slow if we use some kind of this storage database.
And then how do you build a cache?
How would I build the cache?
Right, the cache is at the beginning, the cache is empty, right? Now, how do you build the cache? Because when I send a request to get the feed, then the feed will go to the cache and read it, but it's empty. Right. So how do I get the latest update from my friends?
That's the cold start problem. I think as
Can you hear me?
Yeah. Yeah. See, maybe you can step back a little bit, see what happened if my friend post, right? And how I can see his or her post in my feed. Right? Can you explain to me what the flow look like?
Okay, so we have the cache here, feed cache, and then we will have a consumer over here to consume events from a maybe two topics, message queue, publish to new follow. And then this will consume from the message queue and add to the user feed cache. So the flows is like when a friend posts, right? It will go through the load balancer and request to the post service. When this post is created successfully, no, maybe from the post DB, it can subscribe to the change to from the post DB, and then the consumer will consume the events from a post being created successfully to insert into the follow all the friends. So say A posted, right? The consumer will insert the post ID with the timestamp into the friends of user A feed feed cache. So it will need to talk to the follow service to fetch the follower list of A.
All right. Then what happened?
So for the follow service, similar to this, when a new following is created, the message queue will the message queue will have the events of the record created in the database, and then the consumer will so say follow user ID and then follower ID. Following events. What the consumer will do is that it will get the latest post from user ID and insert into the follower ID feed cache.
Okay, so user ID get the latest post from user ID. So the consumer will, so let's say A post.
Yes.
Then the consumer will listen to the data change, right? The change data.
Yeah.
And then it's get the latest post from the user ID and insert into the follow ID fish cache.
Yeah. User ID, post ID, C time.
So the consumer will get the list of the follow-up A and then insert the latest post to all of the follow-up A.
Yes.
Right. Okay. And how the consumer will get the list of the follower of A in this case?
It will call the follow service to get the list of the of A's followers.
Do you think it would cause any problem?
Would it cause any problem? For say if user A has a lot of followers, right? The consumer will potentially have to write to millions of cache record in the feed cache. and that's very costly for every popular user's post. So for that case, we can have a list of popular users cached in the consumer. And then if the post event is from that popular user, it will not try to fetch the follower. So instead of fetching the post on write, the feed service will try to get the post on read. So it will also have a list of popular users here. On read, it will, so for the something like this, get the feed, get the post ID from feed cache, get the it will need to get the popular users that the user is following, and then get the latest post from them.
What happens if A have a lot of follower and A have a lot of post during a day? Do you see any bottleneck here? A keep posting a lot of post.
So
what happened?
A popular user A posts a lot during the day, right?
And he or she has a large set of follower. Do you see if this I have any problem that you need to enhance?
Large set of followers. So this the feed service would call to fetch to the post service a lot to get the post from the popular users. So getting posts from, there will be a lot of read for popular users posts. But I imagine that the post service will have a cache of its own to handle this. But also, even if we have a cache cluster to store a post, if that one post sits on only one server, it can be a hotkey, and like say for a second there can be millions of people trying to get that post from that cache server. So maybe we have cache post.
Do you think the consumer have some routine that it keep doing again and again?
Sorry?
Do you think the consumer, the MQ consumer, right, have some tasks that it keep doing again and again if I keep posting?
Wait, but we settled that for popular user A, consumer will not try to get the follower list of A, right? With millions of followers.
Why?
and insert into the cache.
Why it will not get the list of the follower? It will send a lot of requests to the follow service to get the list of the follower, right? Could it?
For the list of popular users, I think it's a relatively small list, like tens of thousands of users. So it can be cached. And the list doesn't change frequently, so it can be cached in the consumer. So only for the normal user, it will call the follow service to get the follower list.
Okay.
Does that make sense?
Right. So if just a normal person keep posting, then the consumer need to send a lot of requests to the follow service. All right. So in this case, can we enhance that?
So the problem now is that a normal user posts a lot. Posts a lot, like 10 posts per second. I'm
No worry. Maybe we don't have time, so I think we may spend the next 5 minutes to talk about the database, right?
Okay.
All right. So let's say now the main data we have is the post, and the post have text, photo, and video.
Right.
All right. So how do you store it? And tell me, how do you partition the data so that you can make it high availability and consistent?
Let's see. Let me go over. So for the post database, I'm thinking that we can partition the data by user ID. So we have multiple because for if we partition why I choose user ID, right? If we choose post ID, it's okay for the post service, but when we access a user's say wall, right? The post service would need to query all the databases to fetch the user IDs posts, and that's very costly. Wait. Yeah.
So which key do you use to partition? And why?
By, let me see. If we partition by, let me think for a sec. Post ID, user ID. I would still go with user ID because the home the profile page with the owns user page is a important feature. But now we face the problem of having hot partition or hot shard. So if a user ID, a popular user ID sits on a database, it will get queried a lot.
Right. So any idea that we can solve that?
We can have like read slave databases to offload the read and with cache. What can we do? But then it would still be, for a particular partition, it would still be,
It still be a bottleneck, right?
yes.
It still be a hot. If the user is a big user. Right. Any last thinking before we end the interview here? Okay, let's say if you partition, if you keep partitioning by the user ID and you can use the cache to support the read, right? What kind of cache eviction policy that you are going to use?
Cache to support. I kind of only know on the least recently used.
Right, least recently used. Okay, cool. Right, so I think we have thumbs up. Right. Okay. Rồi. Cảm ơn Đạt đã đến với buổi mock interview, demo mock interview ngày hôm nay. Okay. Thì cái topic social network này thực sự là topic này khá là challenge. Với lại anh cũng combine hai cái vào trong một cái requirement này, nó gồm cả design cái chuyện post mà cái post cũng khó hơn là bằng cách là nó có media. Đấy, cái thứ hai là nó có luôn cái phần là cái feed, cái new feed thực sự là cái đấy khá là khó build. Cái đoạn mà một bạn A của em post lên, xong đấy làm sao để build được cái feed cho em read ấy, mà nó nhanh ấy. Thực sự build được cái system đấy là cả một bài riêng, chứ không phải là một bài này, nhưng mà trong này anh combine lại. Thì về mặt general thì em đã draw được những cái service cần thiết rồi. Đấy, nhưng mà rất tiếc là chúng ta, vì là anh combine, anh cũng hơi là tham lam, combine khá là nhiều thứ này, chúng ta không thể đi sâu vào được với một bài interview chỉ có 45 phút. Right. Generally thì anh thấy Đạt perform step by step và analyze khá là tốt. Alright.
Xanh.
Có muốn nhận feedback gì thêm không?
Có chứ.
Ok, nhận feedback thì
improvement.
Ok, improvement đúng không? Ok, thì lần này thì đầu tiên là lúc đầu em thiếu cái phần, em không biết cái API ra, nên là cái đoạn làm flow thì em hơi chốc một tí, là cái đoạn anh hỏi là em làm sao build cái cache ấy. Nếu mà em viết flow ra thì lúc đấy em đi theo từng API, từng flow của cái API thì nó sẽ smooth hơn, cái cách em diễn giải nó sẽ smooth hơn. Lần này vì em không có API nên em châm thẳng vào giữa. Thì khi anh hỏi là làm sao em build cái cache ở chỗ cái feed service ấy, thì bắt đầu em hơi loạn một tí. Bản chất là khi đi system design, cái API nó giữ cho cái mạch của mình nó mạch lạc. Chứ không có API là giống như em viết văn em không có dàn ý ấy, thì bao nhiêu ký tưởng trong đó em tuôn ra, nhưng mà cuối cùng em sẽ dẫn đến lộn xộn. Em hiểu không? Em viết, em đi thi làm văn mà em không có dàn ý thì ý tưởng em rất nhiều, em rất cảm xúc nhưng em viết lộn xộn thì nó không mạch lạc. Thì cái API nó không là gì đây? Cái API thứ nhất là nó làm cho mình nhớ là mình đang làm cái gì, cái thứ hai là nó giữ cho ý tưởng mình mạch lạc và mình đi từng cái API đấy thì nó dễ hơn. Đấy là một cái trong những cái trick là mình nên cái API viết đơn giản thôi, không cần nhiều và người ta cũng hiểu là cần cái gì. Thì trong này chỉ có một API là post đó, một đây
Positive.
post get feed đấy. Thì tôi với lại thực ra cũng chỉ có hai API đấy đúng không? View detail nữa nếu muốn thì chúng, còn login logout thì ok, chúng ta cái phần này vì cái đề bài nó không yêu cầu login logout thì chúng ta chỉ cần nói sơ qua, chúng ta không cần login này login nọ, chúng ta chỉ cần nói có cái thế được rồi. Thì nếu mà chúng ta đi theo cái flow post trước, sau đấy chúng ta đi theo cái flow feed sau thì cái cách trình bày của em nó sẽ rất là mạch lạc chứ sẽ không đỡ bị jump in the middle thì sẽ hơi hơi loạn
Quên.
loạn đội hình đúng không?
Lúc bắt đầu với em mới quên mất là ôi không có interface.
Có lúc đấy nếu thực sự cái lúc mà em châm vào em phát hiện ra chết rồi, mình quên. Tại vì trong interview thì bao giờ tự nhiên mình sẽ có lúc cái cảm xúc mình quên cái bước đấy thì mình quay lại bảo từ hình như tao quên cái bước này để tao viết vài cái API này ra, thấy chưa? Còn nếu mà em không viết thì interview họ sẽ để em đi luôn. Và khi
À,
em châm vào một cái gì lạ lạ tự nhiên chỗ này anh không hiểu tại sao đang database hết mà tại sao em lại bỏ một cái cache, thì anh sẽ hỏi tại sao không là cache mà không phải database. Thì lúc đấy em sẽ hơi chốc đó. Nếu mà em có API em đi từng flow thì nó sẽ giữ cái dàn bài cho em hơn. Ok. Đấy, còn cái phần mà deal về phần database data partition dùng cái key nào với cái hotkey thì cái hot user ấy thì thực sự cái giống như em nói nó bị bottleneck cái khoản đấy. Đấy, thì cái này thì có một số cái kỹ thuật chúng ta có thể xử lý được nhưng mà chúng ta phải build thêm. Alright.
cảm ơn anh.
Ok, cảm ơn Đạt nhé, cảm ơn mọi người đến ngày hôm nay. Rồi, chúc mọi người buổi tối vui vẻ và enjoy cái buổi demo ngày hôm nay. Xin chào mọi người. Bye bye.
Ừ.